Alright, this is the start of Unit 2. We start with Section 2.3, which is linear functions in slope-intercept form. Okay, a lot of this stuff is going to be reviewed from what you had previously in Algebra 1. Okay, objectives here for this section, as we look here, objectives here for this section, we're going to graph linear function, or we're going to graph linear equations, and we're going to write the equations of lines. Okay, so first couple things that we want to discuss here. We've got some things to discuss first as we look here at this. It says the slope of a non-vertical line is the ratio of the vertical change to the horizontal change between 2 points. Okay, you can calculate the slope by finding the ratio of the difference of the y-coordinates to the difference of the x-coordinates for any 2 points in the line. Okay, now that's a bunch of language, a lot of verbiage there. There's a lot of vocabulary there. Let's get down to essentially the nuts and bolts of finding slope. Okay, slope, the vertical change, how much it goes up and down, versus the horizontal change, how much it changes from left to right. Okay, and you'll notice you have two ordered pairs here. We can find essentially the slope from one ordered pair to the next. How we get from one point to the next, if you were thinking in terms of if you were in a city where it had nothing but straight streets, okay, and you were going from block to block, think about how on the ground in a car, how would you get from one spot to the next? Okay, you can't just go straight across. Okay, you got to take streets. For example, if you went from here to, let's say Kansas City, Missouri, you can't just take a straight shot to Kansas City. You got to go around different roads. You got to go around different curves, stuff like that. Unless obviously you fly a plane. Okay, but in order to find the slope, we're going to look here at this formula. The slope of a non-vertical line through points x1 and y1 and x2 and y2 is the ratio of the vertical change to the corresponding horizontal change, or I'm going to take how much it changes from up and down to left to right, or the difference in the y values over the difference in the x values. Okay, and it says here that x2 minus x1 cannot be 0 because we can't have 0 in the denominator of an equation. We're going to talk about that here in a little bit. But if I move this back up here, and we talk about this, it's probably easiest to write down the slope formula, and we denote slope as with the letter M. Okay, with the letter M, we take the y values and we subtract them over top of the x values and we subtract them. Now, does it matter which x value and which y value you choose? Not necessarily. I could choose, if I choose this one first on the top, I have to choose this one first on the bottom. That's the only thing. Okay. If I were to choose this one on the top first, then this one has to be on the bottom first. Okay. All right. So let's use this and let's go through some examples here now of finding slope. Okay. So what is the slope of the line that passes through the given points? We've been given 2 points, and again we want to plug it into this formula right here. All right. So, the slope is, I'm going to put this in a fraction here, the y values, so I'm going to take 7, which is this y value first, minus 4, over, again, I started with 7, so on the bottom, negative 3 has to go first, minus negative 2. So, 7 minus 4 over negative 3 minus negative 2. 7 minus 4 is 3. On the bottom, I've got negative 3, and I've got two minus signs right next to each other. They're going to cancel out and become a positive, which is negative 3 plus 2. So the slope here is going to be 3 over negative 1, or negative 3. Okay, negative 3 over 1. All right. Okay, letter B. We find the slope here. Slope, the y values, I'm going to take 1 minus 1. Divided by 3 minus negative 4. 1 minus 1 is 0. The two negatives become a positive. So I've got 0 over 7. 0 divided by 7 is 0. It has a slope of 0. Okay. Go down to this third example. Here I'm going to take the y minus the y. Negative 3 minus 1 over 7 minus 7. Negative 3 minus 1 is negative 4. 7 minus 7 is 0. Now, we are going to have a little bit of a problem with this 0 in the denominator. We can't take a number and divide it by 0. So the slope then, anytime I divide by 0, becomes what we call undefined. Okay? Anytime you have 0 in the denominator, you're going to have undefined slope. Alright? Okay, now let's take a look here and let's talk about the different types of slope. There's 4 different types of slope. We've got positive slope, which is the line that rises from left to right. I think of this as you're going up a mountain. Okay? Think of that as you're going up a mountain. You start low and you're going high. Okay? Negative slope, which falls from left to right. This here, I think you're going down the mountain. Okay, you start high and you end up going low. And I'm thinking of this from left to right. Okay? Horizontal line. A horizontal line is what we call zero slope. Okay? And the easiest way for me to think of this and relate this to is the floor. When you walk across the floor, do you go up or down? Well, as you walk across the floor, you're not raising up or down at all. You're staying at the same spot. Okay? So that would be zero slope. Undefined slope is a vertical line. Okay, a vertical line. Now the easiest way for me to think of this one is, and the question I will ask myself is, can you walk up a wall? And no, the answer is no to that question. You can't walk up a wall. If you had a wall there and you tried to walk up it, you'd look pretty funny. Okay, you can't walk up a wall, so therefore it's undefined slope. It's not possible. This case, zero slope, okay, on zero slope is going to look like this, 0 divided by some number. Undefined slope is going to look like this, y divided by 0. Okay, divided by 0. Some number divided by 0. 0 is going to be in the denominator. Okay, now, we're going to use all these concepts to write equations of lines and figure out what kind of slope we have. Okay. Let's take a look at a couple more things here. Special form of a linear equation is called slope-intercept form. An intercept of a line is a point where the line crosses an axis. The y-intercept of a non-vertical line is the point in which the line crosses the y-axis. The x-intercept is essentially the point where it crosses the x-axis. And you'll notice from the picture here, okay, the x-intercept right there is where it crosses the x-axis. The y-intercept is right here where it crosses the y-axis. If I were to write those ordered pairs, this ordered pair here would be 4 and 0. And this ordered pair here would be 0 and negative 2. Okay? Those are the x and y intercepts, wherever they cross the x and y axis. Okay, now you'll notice we see that we have slope-intercept form here. You've seen that before. You've discussed this before. Slope-intercept form. Slope-intercept form is the form of an equation. The line y equals mx plus b. This is very, very important. Y equals mx plus b, right here. Slope-intercept form. Okay, where m is the slope and 0b is the y-intercept. Okay, so what we're going to do is we're going to plug in things into this equation and write equations of lines giving slope and y-intercept. So let's take a look here at these examples now. Writing linear equations. What's the equation of each line? Okay, they give you a slope. You're going to put this in slope-intercept form, which is y equals mx plus b. Okay, so as we look at this here, m is 1/5. So we're going to substitute that in. Y equals 1/5 for m times x. The y-intercept here is 0, negative 3, or it's negative 3, and we're going to put in a minus 3. So all you're doing here is substituting in the y-intercept and the slope to write the equation. Okay, this is your M. This goes in for M. This is B right here. This goes in for B. And this goes in for M. Okay, same concept here on letter B, except for now, they don't give you the slope. You're going to have to figure that out. They do give you the y-intercept where it crosses the y-axis. That's at the ordered pair 0, 4. Now, to figure out the slope, I got to figure out how far I'm going down. So to get from one point to the next, I go down 1, 2, 3. So I'm going down 3. And I'm going right 1. So I'm going right 1. So my slope is -3 over 1, and my y-intercept is 4. And all I'm going to do is plug in the m, which is -3, plug in the b, which is 4, and done. Okay, so you're going to have to be able to write equations of lines in slope-intercept form given the slope and the y-intercept. Okay, the next part that you're going to have to do in this section is being able to graph linear equations. Okay, being able to graph linear equations. So as I look at this here, I've got some steps here for you to kind of follow to give you an idea of how to do this. First of all, you want to put the equation in slope-intercept form, y equals mx plus b, or solve for y or get y by itself. Not every equation is going to be in that form. Number 2 says find the y-intercept and plot that point. Number 3 says from the y-intercept, you're going to use the slope, whatever the slope is, rise over run. This tells you, remember, top number tells you how much you go up or down, bottom number tells you how much you go right or left, to find the second point of the line. And then once you do have the 2 points on your on the graph, then you're just going to connect it and draw a line. Okay, so let's take a look here at this first example. All right, so first step says put the equation in slope-intercept form. So I've got to get y by itself. To get y by itself, I've got to move this to the other side of the equation. So I'm going to do the opposite of it, so I'm going to add 2x here. So now I get on the left side, I have y equals 2x and plus 1. Okay. Step 2 says find the y-intercept and plot that point. Well, the y-intercept is letter B, which is B is the ordered pair 0 and 1. Okay, so 0, 1. So when I find that point, I've got the point 0, 1. I go 0, I go up 1. I'm going to put a dot right there, 0, 1. Okay. Next part, we have to identify the slope from this equation. Well, the slope is the number in front of x, which happens to be 2, or 2 over 1. Remember, the top number tells me I go up, the bottom number tells me I go right or left, up or down, right or left. Okay, I go down if it's negative, I go left if it's negative. Okay, so from the y-intercept that I have here, okay, from the y-intercept that I have, I'm going to use my slope, and I'm going to go up 1. Let's see here, we're going to go so from the y-intercept, which is right there at 0, 1, we are going to go up 2, 1, 2, and right 1. So that's where my new point's going to be. So as I draw this here, it's going to be right there. And then I draw the line between the 2 points. And I've just created my first line. Okay. All right, let's go to example 2. Example 2 is a little bit different here as I look at this. Again, I got to put it in slope-intercept form, so I got to solve for y, or I have to get y by itself. Okay, so in order to get y by itself, I've got to get rid of that 4x. So I subtract 4x. I always want to put the x's first. So -7y equals -4x plus 14, because I want it in slope-intercept form. Now, I got to get rid of this -7 here, so I'm going to divide everything by -7, every part. Okay, -7's go away here, so y equals, I've got positive 4/7 x, and 14 divided by -7 is -2. Alright, so I have a slope of 4/7 and a y-intercept of 0, -2. So first step was to plot the y-intercept. So here I'm going to go down 2, put a dot. From there, this tells me I'm going to go up, my slope tells me I'm going to go up 4 and I'm going to go right 7. So from here I go up 2, 4, I go up 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, and 7. So my new point's going to be right there. Right here. Okay. Right there. So now again I have 2 points. And I'm going to connect the line. Okay. One last question here as we look at this. Again, got to get y by itself. So I get y by itself. I'm going to move the x and the 3. So I've got negative 2y equals negative x and minus 2. Because if I subtract 2 from 1 or subtract 3 from 1, I get that. I take and divide everything by negative 2. I get y equals positive 1/2 x, and negative 2 divided by negative 2 is positive 1. So now I plot the y-intercept, which is up 1, put a dot. And then from there I go up 1 and I go right 2 and I connect the 2 dots. Alright, so we've talked about writing equations of lines and graphing lines. This is section 2-3.